Okay, in this video, I'm going to show you how to solve systems of equations by elimination. First, you want to write your equation so that the terms align vertically. So notice how the x and the x's are lined up, the y's are lined up, and then the constant are also lined up. Then we're going to look for something to eliminate. In order for something to eliminate, they basically have to be almost the same, um, except that one term has to be positive and one term has to be negative. Okay, so we have 6x and negative 4x. Those are not the same. And we have 14y and negative 7y. Those are not the same either. But we could use multiplication to make them the same. So for this one, what I'm going to do is this. I'm going to take the second equation and I'm going to multiply everything by 2. So that's going to turn the equation into negative 8x minus 14y is equal to negative 22. So I multiplied everything by 2. The top equation, I'm going to leave it the same. 6x plus 14y is equal to 6. So now notice that we have a positive 14y and a negative 14y. So therefore we could eliminate the y's now. We can eliminate by adding the two equations. So we're going to add them vertically. So 6x plus negative 8x is negative 2x. 14y plus negative 14y. So these eliminate. And then 6 plus negative 22, that's going to be negative 16. So I'm just left with one variable, and I could solve for x by dividing both sides by negative 2. So now I know that x is equal to positive 8. And now that I know what x is equal to, I'm going to take that value and I'm going to substitute it into one of the equations, and so I could solve for y. I'm going to plug it into the first equation because it looks like it's easier to solve. Okay, so we have 6 times 8 plus 14y is equal to 6. So this is 48 plus 14y is equal to 6. I'm going to subtract 48 on both sides. So 14y is equal to negative 42. And divide both sides by 14. So y is equal to negative 3. So my solution is 8 comma negative 3, and we say that this system is consistent and independent. Let's try another one. Okay, example 2. We have negative 8x plus 2y is equal to negative 10, and negative 4x plus y is equal to negative 2. So you're looking for something to eliminate. Okay. So I'm going to focus on the y's. I have a positive 2y on top, so I need a negative 2y in the bottom. So to do that, I'm going to multiply everything by negative 2. So now the equation is positive 8x minus 2y is equal to 4. The first one, I just copy it over. Okay. Now I'm going to add these equations so I could solve. negative 8x and positive 8x, well, that actually eliminates. 2y and negative 2y, that also eliminates. So that leaves me with 0 is equal to negative 6. So we have an equation that doesn't make sense at the end. So for this one, there is no solution. We call the system inconsistent. Let's try one more. Example 3. We have 6x plus 8y is equal to negative 28, and negative 3x minus 4y is 14. Okay, so it looks like if I multiply the negative 3 by 2, I'll get a negative 6, and that would eliminate with the top one. So let's do that. I'm going to multiply the second one times 2. So that leaves me with negative 6x minus 8y is equal to 28. Copy the top one over, 6x plus 8y is equal to negative 28. So now I'm ready to add. 6x plus negative 6x, that actually eliminates. 8y plus negative 8y, that also eliminates, so that's 0. And then negative 28 and positive 28 also eliminates, so 0 equals 0. So this one is the true statement at the end. We eliminated both variables, and we have a true equation. So that means that this system has, so there are infinitely many solutions, and we describe this system as consistent and independent.